I welcome you all in my YouTube video channel. Today, I will deliver lecture on complex integration, lecture number 16, in which I will solve some more miscellaneous problems on complex integration, Taylor's and Lorentz series. Now, I solve a problem. Problem 1. Prove that cos hyperbolic z plus 1 by z equal to a naught plus sigma n equal to 1 to infinity a n under bracket z to the power n plus 1 by z to the power n, where a n equal to 1 by 2 pi integration limit 0 to 2 pi cos n theta cos hyperbolic 2 cos theta d theta. Now we solve this. Since the given function be function of z equal to cos hyperbolic z plus 1 by z. Here, for z equal to 0 and z equal to infinity, we get singularities. Therefore, at z equal to 0 and z equal to infinity, the function fz is not analytic. So at z equal to 0, it is not analytic, and z equal to infinity, it is not analytic. So function is analytic at the point xi between, therefore the function fz is analytic at all points between z equal to 0 and z equal to infinity. That is, it is analytic in doubly connected region. Let this is number 1. Doubly connected region means if we draw a circle around z equal to 0 and a circle at infinity, the function is analytic between these regions. The function is analytic between this circle and this circle, that is analytic at all points in doubly connected region. Let z equal to xi be a point in the doubly connected region. Therefore, let us draw a circle C. C with center at z equal to 0 and radius equal to 1. Therefore, modulus of xi minus 0 equal to 1 implies that xi equal to e to the power I theta, implies that d xi equal to I e to the power I theta. Let these are number 2 where theta lies between 0 and 2 pi. Therefore, the function f xi may be expressed in the form of Lorentz series. Therefore, function of xi equal to sigma n equal to 0 to infinity am xi to the power n plus sigma n equal to 1 to infinity bn xi to the power minus n. Let this is number 3 where am equal to 1 by 2 pi I integration limit 0 to 2 pi function of xi by xi minus 0 to the power n plus 1 d xi bn equal to 1 by 2 pi I integration limit 0 to 2 pi xi minus 0 to n minus 1 f xi d xi. This is number 4. This is number 5. Cos h xi plus 1 by xi. In place of z, we write xi. This equal to cos hyperbolic. Here xi means e to the power I theta plus 1 by e to the power I theta. This is equal to cos hyperbolic e to the power I theta plus e to the power minus I theta. Since cos e to the power I theta is cos theta plus I sin theta, this is cos theta minus I sin theta. So this is equal to cos hyperbolic 2 cos theta. This is number 6. And this is function of xi. Therefore, from 4, an equal to 1 by 2 pi I integration limit 0 to 2 pi and function of xi is cos h hyperbolic 2 cos theta. This is xi to the power n plus 1. Xi is here e to the power I theta. So this is e to the power I n plus 1 theta. D xi is I e to the power I theta d theta. Imply that an equal to 1 by, here I cancel, 2 pi integration 0 to 2 pi e to the power, here e to the power I n plus 1 theta. here e to the power I theta. So we get here minus I in theta cos hyperbolic 2 cos theta d theta, and this is equal to 1 by 2 pi integration 0 to 2 pi. This is cos n theta minus I sin n theta cos hyperbolic 2 cos theta d theta. This is equal to 1 by 2 pi integration limit 0 to 2 pi cos n theta cos hyperbolic 2 cos theta d theta minus I multiply 1 by 2 pi integration limit 0 to 2 pi sin n theta cos hyperbolic 2 cos theta d theta. This is equal to I1 minus I2. This is number 7. Since I2 equal to 1 by 2 pi integration 0 to 2 pi limit sin n theta cos hyperbolic 2 cos theta d theta. This is equal to 1 by 2 pi integration limit 0 to 2 pi sin, by the property of integration we may write here n in place of theta 2 pi minus theta cos hyperbolic 2 in place of theta we may write 2 pi minus theta d theta. This is equal to 1 by 2 pi here 0 to 2 pi limit sin 2 n pi minus n theta. This is minus sin n theta. Here cos 2 pi minus theta is cos theta. So this is cos hyperbolic 2 cos theta d theta. This is equal to minus I2. Implies that I2 plus I2 equal to 0. Implies that 2I2 equal to 0. Implies that I2 equal to 0. This is number 8. Using 8 in 7 we get an equal to I1 minus I into 0. This is I1 and I1 is implies that an equal to I1 is 1 by 2 pi integration limit 0 to 2 pi cos n theta cos hyperbolic 2 cos theta d theta. This is number 9. Replacing n by minus n we get a minus n equal to 1 by 2 pi integration 0 to 2 pi cos minus n theta cos hyperbolic 2 cos theta d theta. This is equal to 1 by 2 pi integration limit 0 to 2 pi. Cos minus theta is cos theta. So this is cos n theta cos hyperbolic 2 cos theta d theta, and this is equal to a n. This is number 10. Replacing n by minus n in 4, a minus n equal to 1 by 2 pi I integration along C function of xi by xi minus 0 to the power minus n plus 1 d xi. This is equal to 1 by 2 pi I integration along C function of xi by xi to the power minus n minus 1 d xi equal to 1 by 2 pi I integration along the circle C xi minus 0 to the power n minus 1 function of xi d xi. Here in place of xi we may write xi minus 0, and this comes as numerator, and this is equal to Bn from 5. This is number 11. From 10 and 11 we get an equal to a minus n equal to bn, implies that an equal to bn. This is number 12. Using 12 in 3 we get function of xi equal to sigma n equal to 0 to infinity a n xi to the power n plus n equal to 1 to infinity. In place of bn we write an xi to the power minus n. We may write this, if n equal to 0 means a0 a naught xi to the power 0 1 plus sigma n equal to 1 to infinity an xi to the power n plus sigma n equal to 1 to infinity an xi to the power minus n. This is equal to a naught plus sigma n equal to 1 to infinity an common xi to the power n plus xi to the power minus n. This is equal to a naught plus sigma n equal to 1 to infinity an xi to the power n plus 1 by xi to the power n. Let this is number. Replacing xi by z we get function of z equal to a naught plus sigma n equal to 1 to infinity an z to the power n plus 1 by z to the power n. Since function of z is cos hyperbolic, z plus 1 by z equal to a naught plus sigma n equal to 1 to infinity a n z to the power n plus 1 by z to the power n, where a n equal to 1 by 2 pi integration 0 to 2 pi cos n theta cos hyperbolic 2 cos theta d theta from 9, and problem is solved. Now we solve the next problem. Problem is e to the power half c z minus 1 by z equal to sigma n equal to minus infinity to infinity a n z to the power n, where a n equal to 1 by 2 pi integration limit 0 to 2 pi cos n theta minus c sin theta d theta. Now we solve this. Let function of z equal to e to the power half c z minus 1 by z. This is number 1. Here it is clear that if we put z equal to 0, this will be not defined, and if put z equal to infinity, so this will be not defined. Therefore, at z equal to 0 and z equal to infinity, this function is not analytic. Therefore, function of z is analytic in the ring shaped region. This ring shaped region. The ring shaped region is denoted by modulus of z greater than equal to r and less than equal to capital R. Here small r is very small and capital R is very large. This is a circle with radius capital R, and this is a circle with radius r, and center be the origin z equal to 0. Therefore, if xi be a point in the ring shaped region, the function will be analytic at this point. So we may expand function of xi in Lorentz series. So function of xi equal to sigma n equal to 0 to infinity a n xi to the power n plus sigma n equal to 1 to infinity bn xi to the power minus n. This is number 2, where a n equal to 1 by 2 pi I integration along the circle C be any circle in this ring shaped region with center z equal to 0 origin, function of xi by xi minus 0 to the power n plus 1 d xi. This is number 3. bn equal to 1 by 2 pi I integration along the circle C xi minus 0 to the power n minus 1 function of xi d xi, and this is number 4. Now let us take modulus of xi equal to 1. That means xi equal to e to the power I theta, d xi equal to I e to the power I theta d theta. Theta lies between 0 and 2 pi. This is number 6. Using values of 5 and 6 in 3, we get a n equal to 1 by 2 pi I integration limit 0 to 2 pi e to the power half c under bracket e to the power I theta minus e to the power minus I theta by xi to the power n plus 1 means e to the power I n plus 1 theta, and here d xi means I e to the power theta d theta. and we take here e to the power I n plus 1 theta, here e to the power I theta, that means e to the power minus I n theta. Here I and I cancel, so here only remains 2 pi. Here e to the power half c e to the power I theta minus e to the power minus I theta, that means 2I sine theta, and 2 and a half cancel, so here remains e to the power I c sine theta d theta. We take base be same, so power will be e to the power minus n theta minus c sine theta d theta. And we know that e to the power minus I theta equal to cos theta minus I sine theta. We apply this formula here. So cos n theta minus c sine theta minus I sine n theta minus c sine theta d theta. We separate these to integration, and this is I1 and this part is I2. So here I1 minus small I2. By using the properties of definite integration in I2, in place of theta, we may write higher limit 2 pi minus theta. Here also 2 pi minus theta, and we get I2 equal to minus I2, implies that I2 equal to 0, implies that I2 equal to 0. So if I2 equal to 0, here remains only I1. So AN equal to I1, and value of I1 is 1 by 2 pi integration limit 0 to 2 pi cos n theta minus c sine theta d theta. This is number 8. If we replace z by minus z in original function e to the power half c z minus 1 by z, in place of z we write minus 1 by z, in place of z here also minus 1 by z, and this function becomes e to the power half c, here minus minus plus z in numerator minus 1 by z. So the function remains unaltered if we replace z by minus 1 by z. Therefore, into we may write bn equal to minus 1 to the power n an in Laurent expansion. Using this bn equal to minus 1 to the power n an into, we get function of xi equal to sigma n equal to 0 to infinity an xi to the power n plus sigma n equal to 1 to infinity. In place of bn we write minus 1 to the power n an xi to the power minus n. Taking two terms together, we may write sigma n equal to minus infinity to infinity an xi to the power n. This is number 10. Replacing xi by z in 10, we get here function of z equal to sigma n equal to minus infinity to infinity an in place of xi z to the power n. Since function of z is e to the power half c z minus 1 by z, so we write this and right side be same, where an equal to 1 by 2 pi integration limit 0 to 2 pi cos n theta minus c sine theta d theta. Therefore, our problem is solved. Thanks for watching my video. If you are satisfied with my presentation and contents, then please click on like button and do subscribe my YouTube channel. Thank you.